Hello students, today we continue our lecture on gaseous state of matter. This lecture is presented by me, Vanith Ghatak, your chemistry teacher. So let's begin. As you all can see from the heading itself, today's topic is ideal and real gas equations. Okay, so let's begin. The first topic of the day is the ideal gas equation. We have already know certain things about ideal gases. In the case of ideal gas, they are the point masses. The particles of ideal gas are point masses. Okay, point mass. They doesn't have any volume for themselves. So particle of the ideal gas doesn't have any volume. Okay, they are only the point masses, and there is no intermolecular or intermolecular attraction force between the particles. Okay, so there are two things you have to know. In case of ideal gas, the particles of the ideal gas are point masses, and there are no attraction force between the two particles of a gas. Okay, two particles of an ideal gas. So there are no intermolecular attraction force present in the case of ideal gas. Okay, these two things are highly important. You have to know that. Okay, and what are the ideal gas? Ideal gas are those gases who always follow or obeys the Waals law or Charles law. So any gas who always obey the Waals law or Charles law are called the ideal gas. In the case of ideal gas, when we combine the Waals law equation, the Charles law equation, as well as Dalton's law equation, and as well as the Avogadro law, then we will find the equation. This equation is being called as PV equal to nRT, and this equation is called as ideal gas equation. This equation is called as ideal gas equation. Okay, so this equation expresses the condition, the properties of ideal gas. Okay, here we have known that is, here the terms are P, that is P for pressure, V for volume, here N is for the number of moles of gas. This is the number. Okay, this is a printing mistake over that. So N is equal to the number of moles of gas, and R is equal to the ideal gas constant. Okay, so ideal gas constant is R. Here in the case of liter atmosphere, it is the value of 0.082. But remember, and the T is the temperature. So P is pressure, V is volume, and as you know, T is the temperature, and T is temperature. Okay, but here you have to know that N is number of moles of gas and R is the ideal gas constant. But you have to remember certain different values of R. Okay, in the liter atmosphere unit, the value of R is 0.0821. Okay, but in the case of joule, the value of ideal gas constant, that is R, will be 8.314. In the case of arc, the value of ideal gas constant, that is R, will be 8.314 into 10 to the power 7. Okay, in the case of calorie, the value will be in the case of calorie, the value will be 1.987. Okay, so these are the values, or these are the three values of R. So here in the case of R, if we want to express the R value in terms of joule, that is in SI unit, the value of R will be 8.314. In the case of arc, the value of R will be 8.314 into 10 to the power 7. In the case of calorie, the value of R will be 1.987. And as you know from here, the value of R in the case of liter atmosphere will be 0.0821. Okay, so we have to note these values of R. This is highly important for you for doing any kind of numericals you need the value of R in the respective unit. Okay, if the unit is changed, suppose if the unit is changed from calorie to joule, then it will also be changed, then the value of R will also be changed. Okay, so please remember the values of R in respect of joule, arc and calorie as well as liter atmosphere. Okay. So when I am describing the ideal gas, I have told you that there is two things you have to remember. That is, number one, they are the point masses, so the particles of the gas, the ideal gas doesn't have any volume at all. The particles of ideal gas doesn't have any volume. Okay, just for the ideal gas, particles doesn't have any volume, so no volume, number one. And number two, no attraction force, no volume, no attraction force. So these two things is correct for the ideal gas, and these two things are assumed by us. Okay, so for the ideal gas there is no volume for the particles, so the particles are only the point masses, and also there is no attraction force between the two particles, or there is, we can say that there is no interparticular attraction force in case of ideal gases. But in the case of real gas, the particles of real gas have certain volume in it. Also they have certain attraction force in between them. Okay, so there are the interparticular attraction force present in the case of real gas, because real gas doesn't follow the Boyle's law and Charles law completely. Okay, so that is why they have, in the case of real gas, they have, in the case of real gas, they have certain volume. Okay, number one, and number two, they have the attraction force also. Okay, so in the case of real gases, real gas have both the volume as well as attraction force. But in the case of ideal gas, no volume and no attraction force. Okay, but if we like to convert the ideal gas equation into the real gas equation, then we need two terms. Okay, that is because in the case of ideal gas there is no volume term will be needed, because in case of ideal gas there is no volume, but in case of real gas there will be a volume, so a volume term will be needed. And number two, in the case of ideal gas there is no attraction force between them, so there is no attraction force term. But here in the case of real gas we need a attraction force term, the force of attraction term, okay, to justify that equation. Okay, so in the case of ideal gas we need two more terms to justify the real gas scenario. This number one is volume term and number two is attraction force term. Okay, so here in the case of Van der Waals force of attraction, Van der Waals equation, that is for real gases, this real gas equation, here real gas equation is being described by the Van der Waals equation for real gases. Okay, and it is being stated that this is P plus A n square by V square into V minus NB is equal to nRT. Here P is the pressure, V is volume, R is gas constant, and T is temperature, and N is number of moles. But what is A and B? So A, you can see that is here A, and this term and this term is the new. If we omit these two terms, then what we will get? We will get the same equation, that is for ideal gas, PV. Okay, let's take that. We will take these two terms, then PV is equal to nRT. Okay, so if we describe this, if we omit these two parts, this one and this one, then we will get the same equation, as ideal gas. Okay, so these two terms are mainly come from this A n square and V square. This part A n square by V square is the corrective terms for the attraction force or attractive force. As the ideal gas have some attractive force in between them, so it is being called as an attractive parameter or a term for attractive forces. But here in the case of NB, that is this term is being here to correct for the V, that is, as the real gas has the their own volume, as the particles of real gas have own volume, their own volume. That is why we have to add some volume figures as well. This is the for the volume term, that is A and B is the correct for the V of particles. Okay, correct for the volume of the particles, and A n square by V square is the correct for the attractive force. Okay, if you omit this, we will get the same thing, that is PV equal to nRT. Okay, okay. So what is the significance of A and B? The Van der Waals constant A and B both are called as Van der Waals constants. So Van der Waals constants, A represents the magnitude of intermolecular, the magnitude of intermolecular forces of attraction. As I am saying earlier, that is we need to add a term for intermolecular forces of attraction, that is A. For attraction we use A, and for B is, that is Van der Waals for constant B represents the effective size of the molecule, that is the volume. It indicates the volume term. Okay, so B indicates the volume term and A indicates the forces of attraction term. Okay, so please remember the significance of A and B. A is for the forces of attraction and B is for the volume. Okay, to correct the equation we use A and B, both of the Van der Waals constants. Okay, so today we have discussed the ideal and real gas equation as well as the terms and the parameters that have been used, that is A and B. Okay, so this was the last topic of this chapter. So we have finished this chapter by finishing this topic as well. So that's it for today. If you have any doubt regarding this topic or this chapter, please ask me in the comment section below. So thank you very much.